Okay, so this is the project that I'm working on. It's called the time tracking box, or simply TTBox. It's composed of two units, the transmitter unit or transmitting unit and the receiving unit. And as you can see on the screen here, I took two pictures of the transmitting unit and the receiving unit. So the main job, the main purpose of this device is to track time of a nanny. Whenever she comes home, she takes an RFID card. This is the RFID card. So she will just scan it to the RFID sensor, and we will know what time she came and what time she went. I have another RFID card here, and you can get them online. Okay. So when you scan the RFID card into this box, it's going to transmit all the data and time to the receiving box. The receiving box is going to receive the time in the card ID and the time, and it's going to save it into a SD card. Okay, so let's explain a little bit more in details here. So this is the TTBox transmitter unit. So we have microcontroller, RTC clock, RF transmitter, speaker, LED, and RFID sensor. So those are in real world. So this is the RFID here, RFID card here, and RFID tag, RFID sensor, a speaker, microcontroller, RTC clock, RF transmitter, and the LED. And of course we have the power supply too. Okay, so let's make some simulation on how it works. Let me go back to the before we make the simulation, I would like to explain the receiver. So it has a microcontroller, an SD card, and an RF receiver. It's pretty straightforward. So this is the picture. So here we have a microcontroller, a RF receiver, and SD card. I'm going to talk about this yellow thing on the left side later. Okay, so let's go back here. So how it works. Whenever the user scans the card, and this card has an ID, so let's say he takes the card, he scans it on RFID sensor. The RFID sensor is going to transmit the data to the microcontroller. So the microcontroller at that time will request, it will make a request to the RTC about time, and the RTC is going to respond to the microcontroller. So now the microcontroller has the ID and date, time, so it's going to take them and concatenate them. So now it's going to make a separation between them with two underscores, and it's going to send them to the wireless. So the wireless is going to send them to the next unit. So it's going to come here to this wireless receiver. Wireless receiver is going to send it to the microcontroller. The microcontroller is going to just do a simple save. So all the data is going to be saved into the text file here in the microcontroller, in the SD microcontroller. Okay. So whenever we press on the reset button of the receiver unit, all the data is going to be transmitted through the serial COM, because we are using a Mini Pro. We don't have a USB port, but we have to use a serial adapter. But the same concept is true for other Arduino boards. Okay. So how do we read this data now? We have two ways. We can either take off the micro SD card and put it in the computer, and you can just read it as a text file. It's a text file, or you can reset the Arduino, the microcontroller, and the microcontroller is going to send all the data that's in the program. That's in the program. It's going to send all the data through the serial monitor. So let me give you the demonstration. So what you see here on the screen down, it's this unit. So this is the microcontroller, this is the RF, and this is the SD card. And it's connected to the computer with a RS-232 converter. So I'm going to use a software called Terminal by Bry, and then I'm going to clear my console, and it's connected. It's already connected, so I'm going to just connect to port to COM10 with 9600 baud rate BPS, and then I'm at clear, and then I'm going to press on the reset button of the microcontroller, and that will trigger the setup function that will read all the information from the SD card and transmit it to the computer. So here we have all the data, and each time the user scans this RF tag on the other side, and I'm going to show you on the next part. It's far from this receiver, about 4.5 meters, and without using any antennas. So I didn't use antennas yet, so probably it's going to get longer, and I didn't have any problems so far, so that's good. Now let me explain a little bit about the transmission and the data, how it's transmitted. Yes. While I was transmitting the data to the receiver, I used a device called a logic analyzer, and this is a wonderful device for debugging serial protocols and low speed communication, like less than 24 megahertz. So I use this device, and I put it in yellow here, and I put it on the serial monitor, and I was debugging and showing. Because I don't have two serial adapters, so I just used the analyzer to see what's going on. So while I was transferring the data, I was able to see the data in real time and analyze it. So we have 5 bytes of data, and those 5 bytes are the number that you see here: 192, 172. 192, 17, 221, 135, 139, and that's what you see here. That's the card ID. And then I make a delimiter. Delimiter is 2 underscores, underscore, and then we have the date and time. And then at the end of the line we have a line feed and a carriage. So if we go back to the software, and we can see it in more depth. Here we can even see the bits and the length and the code. So this is hexadecimal code, and I can convert it to decimal. And this is the code, yes, and you can see 192, 17, 221, 135, 139, and then I go back to ASCII to see the characters, the other characters. So underscore, and then it goes Tuesday, 2018, just wonder with 2018, January 23rd, that was yesterday, 11:43, and the 04, yes, this is the seconds, 04 seconds, 0D, 0A is the hex code for the carriage and line feed. Okay, so on the next part, I'm going to show you how I scan the RFID card on the transmitter, and yeah, and that's it. Okay. Okay, I'll see you on the next video. Okay, before we move on to the next video, I wanted to address a problem that will eventually occur over the longer distance if we decide to make this distance a little bit longer, and if we have bad antennas, let's say. So what will happen is one of the bits is going to be corrupt, and then all the data is going to be corrupt. So, or maybe one bit is not going to be transmitted correctly for some reason. So a good way is to add a CRC code at the end, and CRC code here at the end for checking the data if it's transmitted in a nice way. But to add this CRC code, we will need two new devices, two new modules. Let me just so we will need a new RF transmitter. So that will be an RFID, right? And then this will be used to send the acknowledgement. So here we'll have a new we have enough space here. We can add a new transmitter. Okay, and on the other side we will need an RX and RF receiver. So it's going to be the same as this one. So, yeah. There we go. This is a this is going to receive data and send it to the microcontroller. I wonder if we have, yes, we do have some extra pins, so we can add a new receiver here. So there should be no problem about that. So if we do that, we'll be able to talk back and forth between the two units, and they can check the data validity, and everything is going to be more let's say professional. And the logic, I can imagine the logic is going to be like this. So it's going to send the packet. If the packet is transmitted correctly, we will have an acknowledgement from the receiver, which is says OK, and if there is a problem, it says CRC error, and then whenever there is a CRC error, it's going to repeat sending the last string. So it's the card ID, delimiter, date and time, and it's going to check if there is a problem. It's going to repeat it, let's say 5 times, and if after 5 times it doesn't work, it's going to buzz. It's going to make a sound for buzz, and if it's OK, it's going to make the OK sound. So so that's one of the things that should be implemented, I guess, in the TTBox version 2.0. Okay, so let's, without any further ado, let's go to the next video. Thank you. Okay, so this is the distance. It's 420 centimeters, which is about 4.5 meters, and that's the transmitter. So look at my RFID tags here. So this is again the sensor, speaker. We discussed about those things before, and one of the things that I didn't discuss is the sound that is emitted when a wrong card is used. So this card, this white card, is not accepted by the system. So whenever we scan it, it's gonna reject it, and you can hear that. Nice. Okay, so it's not accepted. And now I'm gonna scan the blue one, which is accepted. Okay. 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 So now, by doing just that, all the data is transmitted to the receiver unit, and all the data is now in the memory card, and we can connect it. And as you can see, there is nothing, only a power supply here. I'm powering it with 5 volts, so it's independent from computer, so you don't need to have a full server or anything big. You just need the 5-volt supply to record all the data. With some optimization, you can make a small box where you can fit the whole system in an electric box, and it's gonna fit the whole thing in something like that, and that will be your login unit or receiving unit. So that's it for this capstone. I hope you enjoyed it, and thank you for watching. Bye.